Please all stand and let us pray. Good morning, class. Before you take your seats, please pick up some pieces of papers under your chairs and arrange your chairs properly. Miss President is absent today. Okay, thank you. Before we start our class, let me present to you our classroom rules. So this is our classroom rules. First is be quiet when the teacher is talking. Second is respect and listen when your classmates share their ideas. 3. Listen to the teacher instruction and be attentive all the time. Is our classroom rules clear? Okay, thank you. What was our topic yesterday? Okay, thank you. Since you can still remember our new topic yesterday, let me introduce you our new topic. But first, let me present to you our objectives. So this is our objectives. So at the end of the lesson, 75% of the students are expected to. First is define models of incidence geometry. B. Illustrate the figure of incidence geometry models. And last is show interest during class discussion and group activity. So that is our objectives. Before we proceed to our discussion, let us have an activity. Activity 1. The student will be grouped into 2 groups. Each group will be provided with an answer sheet for the connecting point. Connect the point from the given line. Note that every line must have at least 2 points. And illustrate what outcome is. Okay, let's connect the point and know what outcome is. So, as the directions said, let's have at least 2 points. So, let's try. Let's answer this one.
Kapoy?
Oh.
Kapoy?
Oh.
Ha?
Jadi pa.
Kapoy?
Balik ko, balik. Balik. Oh, lanjut.
So the outcome is a triangle. So A to B and A to C, B to C. The A is a point, B is a point, so C is a point. So A to B, A to C, B to C. Okay, all done in activity 1. Let's proceed to activity 2. In activity 2, search and draw. Search an example of hyperbolic plane and draw it. Okay, you must search in Google an example of hyperbolic plane and you draw it. So this is our topic for today. Our topic for today is incidence geometry. Incidence geometry. Incidence geometry is geometry involving only points, lines, and the incidence relation. It ignores the relations of betweenness and congruence. Incidence geometry has axioms. It has 3 axioms. So 2 points determine a unique line. Second is each line contains at least 2 points. 3. There exists at least 3 non-collinear points. So let us have an example. So as axiom said, each line contains at least 2 points. So 2 points. A to B, A to C, and B to C. points. So, as action says, there exists at least 3 non-collinear points. So, when we say non-collinear points, it is a set of points that is not lie in the same line. Let's move to the model of incidence geometry. Incidence geometry model. A model of incidence geometry is a concrete realization of abstract axioms. It provides a specific interpretation of points, lines, and the incidence relation that satisfies the axioms. So the first model of incidence geometry is 3-point geometry. Point A, B, C. Lines A to B and A to C, B to C. Incidence. A point is incident with a line if it is an element of that line. So example, as you can see, there is only 3 points, A to B and A to C. So as you can see, this is the points and a line. So A to B, A to C, and B to C. That is what we call the line. The next model of incidence geometry, the second model is a 4-point geometry. So points A, B, C, D. So as you can see, there is only 4 points. That is why we call it 4-point geometry. So lines A to B, A to C, A to D, B to C, B to D, C to D. So incidence. A point is incident with a line if it is an element of that line. So example. So as you can see, it looks like a kite. So the line is A to B, A to B, and A to C, and A to D. Then B to C, and B to D. So as you can see now, it looks like a kite in real life. So supposedly na it looks like a kite, dude. So the third model of incidence geometry is a Cartesian plane. Cartesian plane. Points ordered pairs of real numbers x and y. Lines triples of real numbers a, b, and c, so that either a is not equal to 0 or b is not equal to 0. It is the set of all points x and y that satisfy the equation ax plus by plus c is equals to 0. So here is an example. So the point A lies on only 2. So that is why 0, 2. The point B point lies on positive 2 and negative 2. That is why 2, positive 2 and negative 2. The point C lies on negative 2 and positive 2. That is why negative 2 and positive 2. So the fourth model of incidence geometry is real projective plane. So real projective plane. So points unordered pairs x, y, z, and negative x, y, z lies on the unit sphere. Lines are set of points x, y, z, negative x, y, z that are parts of great circles in the unit sphere. So, example. So this is a sphere, but this is what we call sphere. So point lies on the sphere. So positive y positive z, and positive x. So those are the points, negative x and negative z and negative y. So let's say that is a ball. So ball is looks like a spear, no? So the line lies, so the point lies on the line. So that is an example of real projective plane. Okay, the last model of incidence geometry is hyperbolic plane. Hyperbolic plane. So points ordered pairs of real numbers x and y where y is greater than 0. Line. Subset of vertical lines that consist of points x and y with y is greater than 0. So example. So the hyperbolic plane, no, part of incidence geometry, it looks like semicircle or half circle. Example is this one. So the point x and the point y. So it lies on a line. So those are the 5 models of incidence geometry. So what can you say about the incidence geometry? Okay, very good. What are the three axioms of incidence geometry? Okay, very good. It seems you can still remember our topic. Let's proceed to group activity. For group 1, directions. Connect the point using the given line to make a figure and explain what figure it is. So L, M, N, O, Q, L, N, L, M, N, M, N, O, N, Q, M, O, M, Q, Q, O, Q. So these are the points L, M, N, O, Q. So try this. So for group 2, arrange these jumbled letters. So arrange the jumbled letters. Okay, thank you for your cooperation in our group activity. Okay, let's proceed. Let's continue to in real life situation, incidence geometry. It is a design to analyze the stability and strength of a building structure. To sum up the lesson, what we have tackled today, what is incidence geometry? And what are the models of incidence geometry? Okay, thank you. Let's proceed to evaluation. Kindly answer this. For an assignment, research more about incidence geometry. Goodbye, class.